Hi, my name is Bobby Harrell. I'm the Business Development Manager for Strand and Verilight, concentrating on systems. This class is about the VisionNet Lighting Management System. To discuss VisionNet as our system-wide control platform and how it functions, what it can do, how systems can be engineered, how the system thinks, and we'll go from there. So some of our facilities that jobs that we've done that we would consider small and medium scale. The Centre de Congress Convention Center up in Canada, the Intercontinental Hotel on 44th Street in New York City, Skidmore College Recital Hall, and facilities we generally consider larger scale. The Tampa Museum of Art, the Marriott Palms Resort in Florida, the Wiley Theater in Dallas, and the largest indoor facility in the world, the Qatar National Convention Center. So VisionNet as a lighting management system is a completely scalable architectural control platform. So VisionNet functions on areas, and an area can be a control location. You could consider an area to be a floor of a building. It could be an auditorium in a school. And VisionNet is now scalable up to 1,000 areas where each area can contain 255 rooms. So a room for VisionNet could be a section of a ballroom. It could be a classroom. It could be simply a controlled division, a dividing block, a container of controls. What is typical for our commissioning agents for a school auditorium is to put all the house lights in one room and all of the stage fixtures in another room. And by separating that control, it makes it very natural to allow the ability of storing all house light channels in a particular preset and have that not affecting any of the stage fixtures, and vice versa with the stage. So that's the whole purpose of the areas. It uses an open design of an Ethernet backbone that connects to the touch screens for extended control. With control over multiple areas, you can do building-wide and campus-wide commands with VisionNet. So to understand the scale of what we're talking about with the Qatar National Convention Center, here's a list of all of the items that were used in that facility. So it's over 11,000 dimmers, hundreds of control stations, aux sensors, touch screens, well over 100 C21 dimming racks, over 100 meeting rooms. So a fairly large system that's actually under 3 different structures. So VisionNet is a very maturely evolved product line. It started back in the early 90s with multi-set and has advanced through these different versions, becoming VisionNet in 2007 to the point where we're now on VisionNet 5 that we launched in 2019. So basic system architecture for VisionNet. So how a system can be laid out for communication. On the left, we have an example of our A21 cabinet. A21 can contain combinations of dimmers and relays. It communicates, in this particular case, it's communicating to the control stations directly. The device in the middle is a programming station. So this is where the commissioning agent would take their laptop and connect into the system either via USB or serial. And this is where they would upload their programming into the system. And all of this is connected via Cat5 control cable. And you can see here we have different versions of stations. We have button stations. We also have what we call a combination station, which has a single gang series of buttons for presets and a single gang of a 4 slider station, where the first slider is a master and then the other 3 would be controlling individual items. So that was a very simple example of the architecture. As the systems as the need for the system grows, you often would find yourself needing to put stations in very different physical locations throughout the space. So you may need, in the school auditorium, you may need some stations on the north wall, some stations on the south wall, and it's not convenient to daisy chain all of those with one run. And you also might exceed limitations anyway. So this is showing a larger system where the main rack is it's a full C21 or EC21 rack that could have dimmers or relays or constant modules. Then it goes to a 4-way splitter. This simply allows for the ability to distribute VisionNet communication control lines into four different lines for daisy chaining stations. So that's really all that 4-way splitter is doing. So there are 4 lines going out, each going to a different area of the facility, accessing those various stations. In one of those lines, you'll see there is a programming port, which will allow the commissioning tech to connect his or her laptop into the system to upload and download configuration information to the stations. There is a specified limit of 20 VisionNet stations per line on a 4-way splitter. However, most commissioning agents have learned to be a little more conservative and keep that to under 20. Very similar to the way DMX has a maximum device count of 32 devices per daisy chain DMX line, although you don't really find any production electricians that will put that many on a line. It's just not worth the risk. If you are using a serial line, you can go up to 1,500 feet. If you're putting this line down Cat5 cable, we do recommend maintaining the Cat5 limitation of 100 meters per line. So growing out the idea of this system architecture. So this will probably be the one place where we'll talk the most about how VisionNet thinks and why these connection points in this layout is done this way. So here we start with the racks. So we have a C21, EC21 rack. We've got a picture of an A21 rack, but as you can see, these are just generalizations. These could be C21 or EC21 racks, A21 cabinets, contact relay panels. The R21 and S21 are distributed dimming and relay products, so they would be integrated directly with the raceway at the electrical position itself, at the electric or the line set. Then you can come out of these devices and go directly to the fixtures. Those would just be traditional circuits for dimmers. But if we look on the other side, we're going to communicate with the touch screens. They can be communicated to both using the serial connectors, serial line RS-45. They also can be connected directly through Ethernet. If you have an Ethernet backbone, you can have a Wi-Fi connectivity. One thing that we have just recently released is what we're calling VisionNet on the go, which will allow you to wirelessly connect into your VisionNet system through a web browser, which means you can pretty much use any device, any platform with any operating system to get a touchscreen control of your VisionNet system. So here we have a touchscreen over the RS-45 line. We are talking to keypads, button stations, slider stations, and wired directly to the keypad. They have input-output ports where you can attach and have sensors. So occupancy sensors and photocell sensors can connect into the system directly through the stations. The way that VisionNet thinks, and this is important to understand, is that VisionNet is distributed intelligence. So there's no single point of failure within within these facilities. So let's say you have a button station, and that button station has 8 buttons on it, and the first 6 are set to be presets. So you hit a button, it's going to trigger. You hit button number 1, it's going to trigger preset number 1. All that's stored on that station itself is the trigger for preset 1. There's no content that's stored on that button station. The content is actually stored directly in the rack. So whether it's contact rack, S21, R21, A21, or C21, E21, the preset that it is triggering is stored in the rack. So that's always been pretty simple with dimmers. Then the dimmers would go to the preset level that's been stored, and the lights would go to that level. Now that we're in a world where we're not just dealing with dimmers, we're dealing with relays, the same thing occurs, right? The relays are there in the rack, so they have their level stored directly in the rack. However, once we go to attributed fixtures, so LEDs, moving lights, DMX controlled house lights, we need a place to store that data. So that's what that VisionNet to DMX card is for. The VisionNet to DMX card stores all the preset data for the universe of DMX in which it is configured. So the way that the VisionNet to DMX card is engineered to be part of the system is it is typically done, I mean, it can be done directly with RS-45, but it is typically done over a network. And when you have your fixtures that are all daisy chain DMX, but they're getting onto the network through a node, and there's a picture of a node there at bottom center. With the lights getting onto the network, you have to have that VisionNet to DMX card on the network as well. So typically what is done is there will be a rack mounted node in an equipment rack, and what you have to do is take one DMX port, come out of the network and go into the VisionNet to DMX card, and then come out of the VisionNet to DMX card and go back into the network using a second DMX port. So for every DMX universe that one needs to be on the VisionNet network, one would need 2 ports on a node in order to come out of the network into the card, out of the card back into the network. So a typical 4 universe system would have an 8-port rack mounted node where you would come out and in and out and in for those 4 VisionNet to DMX cards. And then that will allow the data to be stored on the card for output to the fixtures, as well as that distribution can happen over the network. So we've got the touch screen, we've got our fixtures connecting to the VisionNet to DMX card, and now the VisionNet to DMX card is on the network. The third party or the programming port can be connected to third party devices for AV control. We also have done some jobs with echo shade control, where they're connecting in through that VisionNet to DMX. I'm sorry, through that programming port. There are also hub and AV cards to do AV input output and expand the distribution of this communication. So going further, if you take that architecture that we just showed and you expand that to think of that as one floor or one building, and that would be an area, or it could be multiple areas, in fact. So you can stack those and expand and increase, and now you can have neo consoles or the Neo Playback Controller, you can have nodes, you can have VisionNet Designer that can communicate to all of this on a system-wide or campus-wide level of command structure. So this can all just continue to expand and add on as needed for the facility. And that's essentially the way our install at the Doha Qatar National Convention Center works. Is Area 1 was one building. We've got that set up. The architectural components of that building are set up as stage 1. We have areas 2 through 5, which are distributed as the different production areas within that, and then area 6 added the architectural for stage 2. So VisionNet is distributed. There is no single point of failure. If a touchscreen goes down, the system still functions. If a button station goes down, your system still functions. They just need to be, repaired or replaced. And that helps make this system future-proof. And we've been developing this for years, so we will continue to do so and expand upon its flexibility. So VisionNet Designer software, it's a Windows program that has drag and drop tools that allows any commissioning agent to visualize their control project. You've got flexibility for button sizes, colors, sliders. It's really an open design system that you can design for your needs. The VisionNet Designer software also contains a customizable fixture library. This allows you to patch and or build fixtures for attributed fixture control. So this could be LEDs, this could be moving lights, really anything that has a DMX map to it. So the VisionNet design software, it's very, very powerful control. You've got standard architectural commands that are available, presets, toggles, smart buttons, which are essentially macros, raise and lower buttons. You can link rooms for multiple section of room applications like convention centers and ballrooms. You got share buttons, toggle masters, astronomical time clock events. So these are all available within VisionNet. There are up to 32 presets per room. It's very flexible. If you have a button station configured and you want to store a new look onto that preset, all you really have to do is set your look, whether you're setting it from the architectural system or the theatrical console in a school auditorium situation. You would then go to that button, press and hold for 3 seconds. It will flash, and it has now captured and stored that look onto that VisionNet preset. And it's just that simple. So for fixture control in the configuration, it's just a matter of selecting the manufacturer, the fixture, and the mode. Then you create a slider or a button that associates with that fixture, and then once you have that, you would simply select that fixture at which its attributes interface would pop up to allow you to do your control, and in the case of an LED, select your color. So VisionNet fixture control. The images on the left are showing the different options. You do have color pickers available for color mixing fixtures. If that fixture had a color wheel, you could go into its wheel control. The middle image is showing that you do have slider control for each of those color parameters, RGB, white, amber, whatever they may be. And you also, for moving lights, you also have a target box for pan and tilt control. So it does give you an interface for controlling all the parameters. Again, we have the remote control with the VisionNet on the go for an iOS device, could be a phone, could be an iPad, Android devices, tablets, Windows, Mac. I mean, anything that has a web browser could access this, because technically what it's doing is simply serving up the touch screen that's in the system as a web page. and it's serving up, and then you can access it from any device that you have. And then over the Ethernet, we would have Ethernet nodes, which is going to communicate the data from Ethernet out to DMX, which would then go to the fixtures. So time clock events. You can have one time clock device on a system that typically comes from, in our older systems, that came directly from the touchscreen. Now with our newer technology, that will come from the VisionNet gateway. The gateway is something I'll talk about in a little more detail shortly. So you have calendar-based astronomical time clock events that are easily programmed in the VisionNet software. You have only on and never on exceptions. Event messaging is available and supported. And there are sweep commands that are available for after-hour occupancy. They can be triggered by the time clock or manually. Touchscreen customization. With your buttons and sliders, they have properties that you can customize for style, size, color, font. There are modes and states within this system. Now, a typical mode or state might be in a school performance facility, performing arts center. You may have a performance state, a rehearsal state, or a classroom state. And what the performance state might do is lock out stations that are accessible by the audience, so that no one at an egress location could lean up against the station and activate a preset by accident. You may also have on stage both work lights and running lights, and the on stage stations, when you go from one state to another, it might turn off accessibility to the work lights so that they can't be turned on accidentally during a performance. And now those stations, instead of controlling work lights, will now control the running lights. So those are the types of things that you can do with VisionNet and with modes and states. Artwork and graphics can be imported. So if you have a touchscreen in a convention center ballroom, you could upload the artwork for the client who's coming in for the day. And you can also password protect stations to provide a security level of control. So the basic premise about VisionNet is it is completely scalable. You can expand your system based upon your requirements at design or at any time after the system is initially commissioned. It is distributed intelligence, so it uses distributed processing techniques to ensure system security. And because it's distributed, there is no single point of failure to compromise the system. There's very quick design with the VisionNet Designer software, so it has drag and drop design, making the design of those screens very quick and simple. So a little bit about the distributed intelligence: no single point of failure, room control provided by button stations, slider stations, and or touch screens. You have AV interfaces, RS-232 and RS-45, serial communication, USB, Ethernet protocol. The VisionNet Fade Engine software resides in the control processor of each dimming panel, or dimming or relay panel, or in the VisionNet to DMX cards. You can have up to 1,000 panels with 96 dimmers each, plus the 512 DMX slot per VisionNet to DMX cards, so you can configure up to 1,000 VisionNet to DMX universes. So it's very scalable, from simple house light control to very complex lighting facility management. So let's talk for a moment about control surfaces. We have button stations. The button stations can be purchased with just one button or up to 8 buttons per single gang station. The hardware itself has all of the guts for all 8 stations. It's just how many of them you expose with button covers on the front. Functions can be assigned on a per button basis. Custom colors and for the covers and labels are available. Slider stations, they can go from 1 to 15 sliders plus the master. Essentially each each gang is a 4-slider station. Every slider station has all 4 sliders in the guts of the product. It's only a question of how many of those sliders are exposed on the faceplate. And you can expand and go to multiple gangs to get out to 16 sliders. These sliders can be sliders per channel. They could be submasters. They can also map to our Neo console and control Neo submasters. And I'll talk about that connectivity toward the end of the presentation. We have new 10-inch touch screens. These can be wall mounted, flush surface. They can be mounted in a portable station, which can be very typical for school jobs. The electronics work with specific sizes that are available, so we can disassociate the electronics of the touchscreen with the screen itself, and then you could specify, for example, a 19-inch touchscreen that might be mounted in an equipment rack in the equipment room, and just use the electronics from the back of it. So there's a lot of flexibilities with this system. The other device that's showing here is the new VisionNet gateway. So the gateway serves as it literally serves as a gateway between the VisionNet network and the outside LAN network within the facility. It's a DIN rail mounted power over Ethernet device that's very easily installed in a variety of locations. So this makes it easier for configuration by the commissioning agent. So the gateway provides the astronomical time clock that the touch screen would access. It also has an NTP server, so it can synchronize clocks to all devices from the one time clock here. It also has an onboard DHCP server, so this can automate IP addressing for all the VisionNet devices, and it can also provide connectivity to the facility's LAN network for future network-based functionality and services. Okay, so with the gateway, some of the features and benefits: it is power over Ethernet. It does have the astronomical clock and the NTP server. It is DIN rail mounted. If you need, you can do an external power supply. It would plug into the green power port that is shown there. There are 2 network interface cards on this. Being that it's DIN rail mounted, this also is engineered to be expandable. So it's a little hard to see on this image, but there's a connection port on the side. We will be expanding this DIN rail offering to include additional modules. For example, one of the modules that we have just released is the ability to have a module that just slides onto the DIN rail, connects into this connector, and that's all of the installation that you need to do for the module. And this particular module has Phoenix connectors to allow you to do direct connectivity of the line to stations, to button stations and slider stations. So it starts to replace things like that 4-way splitter that might be needed on certain jobs. So the target markets for this are theaters, educational facilities, house of worships, museums. It could also work very well in restaurants, small retail. So there are a lot of applications for this and a lot of value in those markets. So key benefits: we've got a sleek, modern design touchscreen in the 10-inch, direct connectivity to Ethernet with power over Ethernet, distributed topology. It's fast to implement and deploy, fully integration with dynamic control elements. It's a modern operating system, completely scalable from simple rooms-based to campus-wide applications. It links to other control and power distribution products via the protocol bridges. It's completely expandable at any point. The simplicity for ordering with common screens and accessory. easy to install with modular mounting options and a 2-year limited warranty. So the touchscreen itself does have the PoE Ethernet connector. It's got the serial port. There are USB ports for uploading configuration files manually, although I think most people will upload that over using Visionet Designer software over the Ethernet. And you've got the Phoenix connector for the RS-45 connectivity into the touchscreen. So it's a new sleek looking assembly. There's a wide array of mounting options and modern operating system and the PoE power with the Ethernet native capability. So we do have options for flush mounting, surface, desktop, rack mounting, and there is a locking cover option. So talking for a moment about basic connectivity, you've got the programming port, which will allow you to connect to the system either via serial or USB. It can also be used in connection from an AMX or a Crestron system for third-party connectivity with AV control. The 4-port splitter allows multiple Visionet subnets to be merged into a single segment. The DMX node interface acts as a gateway for connecting to DMX input and output devices. There are 8 input-output AV interfaces. So we do offer occupancy and photocells. We also connect with third-party occupancy and photocells. So the occupancy sensor is going to turn lights on and off when needed based upon their perceived occupancy of a space. The photocells are going to prevent lights from turning on when the ambient daylight reaches a certain level. The way this works in Visionet is you set a low light preset, which would have more artificial light, and a high natural light preset, which would have less artificial light created. And it uses the input to the photocell to vary its output between these two states. And you can configure how fast or slow it responds going between those two states. So the sensors can execute any Visionet command across the network, whether it's presets, whether it's smart commands, any of that can be triggered. For our sensors, the viewing area when mounted at 12 feet at 360 degrees is about 40 feet, and this supports a total coverage area of about 1,200 square feet. So I wanted to talk a little bit about the connectivity between Neo and Visionet. Typically, a school auditorium facility is likely going to have 2 separate control systems. It is likely to have an architectural control system, which would be Visionet, which is available 24/7. The system is always on. Then you have theatrical control, which would typically be a Neo, which is usually only turned on for more advanced programming states, for performances, for any scripted environment where you need more than just basic control. We have been working to build bidirectional capability between Visionet and Neo. And I'm going to talk about some of the different ways that you can work with these two systems to add a lot of power. So this is outlining what is typical, where you have both systems that are operating, they're outputting, you have the entire patch of the entire system in both locations. So every LED and moving light would be programmed in the Visionet as well as programmed in the Neo. You would likely have control of relays from both sides and dimmers. So this is the most traditional way of working. There's no connectivity between these two systems. They don't really know the other is there, and they're both operating independently. I mentioned earlier that you need Visionet to DMX cards per each universe so that Visionet can see the data from on the system for snapshotting purposes. Purely on an economic of scale standpoint, now this isn't about what type of control you need, but just on pure economy of scale, once you get above 4 universes, it's actually cheaper to no longer go with that same architecture of having VisionNet to DMX cards, because once you get beyond 4 universes, you need an additional node, an additional 8-port node to continue to have network ports or DMX ports available on the network to add additional cards. So just from economy of scale, it is cheaper now to go with Neo, have Neo do all of the outputting for your control, and your VisionNet stations, which are distributed around the facility, are simply triggering Neo. So they are triggering presets that have been stored on Neo. Their sliders are mapped to submasters on Neo. At that point, you have a more scalable solution because Neo can go up to 100 universes. There are no VisionNet to DMX cards that are needed. The downside to it is that if Neo is your essentially your architectural processor, then it's going to need to be on 24/7. And at that point, what we usually do is engineer this system to where this communication is happening, but the Neo that it's communicating with is a rack Neo, so that's in an equipment room, it's on 100% of the time, and the Neo console, there would still be a theatrical console, and that would be a Neo as well. So this is just talking about how you can output over Neo and have VisionNet do all the triggering. And it's a very flexible, expandable system that way. Now, the last way that you can look at controlling we're having Neo and VisionNet work together is to have Neo be that architectural processor, as I was talking about a minute ago, and VisionNet do the triggering. And here you actually have bidirectional support. So VisionNet still has the configuration and the patch for the whole system, but it's all triggering it through Neo. And again, the point of doing this is really about scale and the economy of that scale. So again, most systems that are at 4 universes and below, sticking with the traditional way of working of having VisionNet and Neo being the theatrical controller be separate is probably still the best way to go. But it's when you go beyond that you generally get benefit out of going with a Neo-based processor system. For anyone that has a job that's interested in doing this or want to learn more, happy to have direct conversations. The salespeople can talk about this. I can discuss it. Our field service engineer, Maggie Bailey, deals with a lot of these jobs. So we can talk to you about this in more detail should you need it. So that is basically the overview of VisionNet. So again, a very expandable system, no central point of failure. It's all distributed processing. It has a lot of intelligence and has been installed in hundreds, if not thousands, of installations over the years across the world. And we're very, very proud of what we can do with it, and especially its expanded control with Neo and everything that we can do there. So I could talk about some examples of what we're doing with it. We've got a high school that I did the training on recently, where we have done just this. We've got, it's a fairly large school. It's got, I think it's got six or eight universes. And we have a rack Neo as the architectural processor. VisionNet is simply triggering it. But they also have a theatrical console, Neo. And when information is triggered between VisionNet, when VisionNet's sending out a trigger, actually both devices are listening because it doesn't really care what's hearing what's doing. So if I activate a house light preset on VisionNet, it's actually sending that signal to both consoles, and so the rack is actually doing the outputting, the console sees it, so it shows up on screen so that everything is transparent and available. And if the console were to be turned off, you still have the rack processor, which is listening for all the triggering. We did a similar thing with the Royal Canadian Mounted Police's brand new 100-meter firing range earlier this year, where there's a rack Neo in the equipment room that's actually doing all the processing and triggering, but the people, the RCMP officers that are running the gun range are triggering everything through touchscreens. So another question, what's the smallest setup possible with a DMX module? I guess I'm not sure what you mean by a DMX module. If you're meaning a VisionNet to DMX card, the smallest setup would be, that's for one universe. So that would be snapshotting and capturing up to one universe worth of output. So that could be one LED or up to as many LEDs or movers that could fill up a DMX universe of 512 unique addresses. Can use only a DMX card alone. Well, the DMX card is there to capture that data that VisionNet would trigger. So what you're looking at, if you don't really have, let's talk about theoretically the smallest system. So if you have a VisionNet card that needs to capture up to a universe and you have a way to trigger it, then your smallest system would be a button station and the VisionNet to DMX card, right? You'd have to have a power supply to power that up, since you don't have anything else. There's no dimmer racks, no relay racks, no anything else. So there would be a small tray with a power supply. There would be a button station, and then there'd be the VisionNet to DMX cards. So that would be your smallest system. So hopefully that answers your question. Okay, sounds like it did. Thanks for attending today's online training session, and hopefully this helps. All right, bye-bye.